Hello and welcome to another episode of Ken Training. Today's training, what we're going to do is we're going to be working on a residential air conditioning split system with a furnace, doing an annual PM preventive maintenance and performing a check, filling out a couple of checklists to determine the health of the system, to see how well everything is operating. First off, this is in my own home. I've been living in this home for about, let's just say, 9 years. And the AC system is the original system, and it's 40 years old. The house is 40 years old. It's the original AC system. It's 40 years old. It's an R22 single stage furnace and AC unit. Both of them are single stage. And the system actually operates pretty good. I actually don't have an issue with the AC system. All I'm doing is performing an annual just to give it a good service, as well as give a training video for you guys. Now, as far as my qualifications go, so normally a lot of my HVAC background is geared towards commercial HVAC units and working on those. I don't, other than my own home unit, I really don't get a lot of residential experience. So take the training with that thought in mind. I'm not like a regular service guy that has a service truck where I'm servicing residential AC units every single day for a career. So I just work on mine intermittently. So the tools that I have are not going to be the best tools for that an HVAC service tech who's got a service van that's doing service calls every single day is going to have. So I'm just more of like a DIYer doing my own type of preventive maintenance and service. So keep that in mind when you're watching this video. So I like to use checklists for my preventive maintenance for a couple of things. It helps me know what I should be looking for, and in case I forget something, as well as I have a written documented log. I probably should have done this 9 years ago when I first moved in, to have a baseline to figure out what's going on. But you know, other priorities and other things coming up in life, and it didn't really address it. Just kind of did the normal servicing. Now, I've already done some servicing to the unit behind me. So this house is a 2-story house. The air conditioning unit is one system for the entire house. It's located in this closet right here, and I'm on the 2nd level right now. So the furnace with the AC coil on top feeds into the attic, and then there's a plenum that goes to branch ductwork that feeds down. When the AC contractor went and did the original job, what they did is they put the supply registers towards the doors of the bedroom. So right now we're in one of the bedrooms on the 2nd level. Personally, I don't think that was a good installation. I think that would have been better had they installed the supply register closer towards the window exterior wall, and then allowed the return to either come through the open door or have the door cut, so this way it would come underneath the door that way for your airflow in order for the system to breathe. It would have required a little bit more duct work, because instead of going and terminating here closer to the furnace, they would have to terminate at the exterior walls. So probably due to costs, the original contractor just does it the absolute cheapest way they can get out of the situation and still provide and say we've got air conditioning, so they put it right there. And for me to go and change it, there's 2 things that I'd have to do. I'd have to cut a new hole in the ceiling, and then patch and paint this hole, and texture and paint. Patch, texture, prime, paint this up. So unless I'm going through a complete brand new duct job, I'm not going to go through all that heartache of doing all that work, because then you're dealing with patching and painting on the inside too. So it's let's just say, you know, to change it, it's a project, okay? And I'm not going to certainly do that on this video, but that's, in my opinion, that would be a better installation, to have it towards your heat and cooling loads, which is towards your exterior of the house, and that way, as the air comes through the room, it has better blending to allow greater. Not only that, if we supply it at the ceiling and we return it at the undercut of the door, you're getting the least amount of stratification of air within the room, so you're going to get a more blended temperature. To me, it would have been a better install had they done it that way, but they did not. So I just talking about that because I'm talking about HVAC in general for this training video. There's my website address right there, kencogliano.wexsite.com/Ken Training. There'll be a link to it in the bottom of this video. Now, this is a brand new checklist that I just created. So you can see what I've got here is I've got a picture of a HVAC system. You've got the return air coming in, coming down the return duct right there. You can see the arrows, and then there's I have the red dots are where sample points are located, and then on some of the red dots you can see I've got them numbered. So this first sample point, which is just before the filter on the return duct, is point number 1, and then inches of water column is how much static pressure is at that location before the filter. So I'm trying to determine exactly what's going on the ductwork and to see how well this system is breathing. So we're going to do that, we're going to do sample readings with a Magnehelic gauge. This here is a Magnehelic gauge that I have. Luckily I did not have to purchase it, I already had one. This one goes all the way from 0 to 2 inch, but in reality you could just use 0 to 1 inch. But if I was going to purchase one, I would not purchase one of these. What I would purchase is one of the new digital ones. This one's 20 years old, so I just happen to have it, and that's why we're going to use it. And that is how we're going to fill in this information. And as I go through the system, I'll show you that. And then point number 2, the return air temperature dry bulb and return air temperature wet bulb. I have a special thermometer. Where is it? Right there. This particular thermometer here that I have will give us that information when we get to it. So we're going to go through and fill out this checklist and determine how everything is, the health of the system. We're going to try to figure out our CFMs. Now, the CFMs are a tricky one because I don't have an anemometer. I wish I did, but I don't. Now I do have some formulas here. This is a airflow for AC. We'll go through that so we can get the AC. We're going to get some temperature readings, supply air temperature, cooling and heating, and the inches of water column at sample point 4, which is after the AC coil. We're going to get the delta T, which is the temperature difference, which is 0.3, which is that point right there, minus 0.2 over there. So we'll go through the whole thing and make sure that you got it 100%. To get the heating CFM, you can see here I can figure out the heating CFM equals the BTU output divided by parentheses 1.08 times the delta T. And we'll go through all that so that you get exactly what it is. Your delta T is right there once we fill that out. So we'll go through this entire checklist. So that's one checklist right there. This here is the second checklist. I've got it broken up into 2 different segments here. So I just call this AC checklist. You know, it's got the AC unit, date, name of the person doing the information, refrigerant and temperatures and pressures, and then here's a little refrigeration cycle. And now the top section is the refrigerant temperature. The bottom section is the air temperature with the same refrigeration cycle. So we'll go through all that and we will fill out all this information. If you had multiple compressors, compressor 1, compressor 2, or if you had different stages, compressor 1, stage 2, but my particular system is just a one compressor system, and it is a single stage for heating and cooling, so we don't have to worry about any of that. It's the simplest system that you can. My system, just being a single stage system, 40 years ago, I think that's all they had for, that was just what they had 40 years ago. Today, you can get two-stage systems, variable speed systems. They have a plethora of different products that you can choose from. They've got mini splits where they're trying to sell you where you put in one condenser outside can feed 4 mini splits, which can be good and can be bad. It can be good because you can put one supply head in each bedroom and individually control that one bedroom with that one evaporator coil mini split. But then in addition to that, which they never discuss, each time you do that, the refrigerant and the condensate line have to be addressed at each of those locations, which can be a complete headache because your goal is from my perspective, your goal is to try to keep the refrigerant all within the least amount of areas as possible, because refrigerant is the portion that can leak, and what you're looking for is a sealed 100% tight system. Once you get a leaker, trying to do troubleshoot on where that leak is let's just say not fun, and sometimes you're just going to end up replacing those components. So if you have 4 units, you have 4 additional components, 4 additional points of failure, more complexity to the system. The benefit is that it gives you individual thermostat control. Well, you could do the same thing with a single central AC unit, and you provide duct zoning. So there's so many different options today in 2019 that weren't available 40 years ago. They didn't have all this fancy things that you could do in the home practically. Today it's becoming more and more practical, where people are putting more and more emphasis on HVAC. But let's get back to our system here. Again, we want to do an annual PM. I've already kind of started this and dug into it, so I'll show you where I'm at and then take you through it. I put a light on the floor there so things are a little bit easier to see. Again, this is a 1 unit feeding an entire 2-story structure. We're on the 2nd level. For the returns, that's 1 return here at the 2nd level, and the 2nd return is the same kind of thing where it's into the framing of the house, the drywall cavities down below on the 1st level. Now I've already taken the doors off. There's 2 doors. This is the lower door, that is the upper door. I have a shop vac here so I can use wet and dry functionality, so I can do my stuff with that. I removed the blower housing to look inside because I wanted to check out the wiring that we have here to see what's going on with exactly what speed is what. This thing is so old that these wires, you can barely see the colors, but it looks like, well, obviously this one's a white, but as far as these other 3 colors go, I think this one here is a red, this one here is a black, and this middle one might be a black too. So I'm assuming that what we have here is a multi-speed motor. So I took apart where the transformer is right here. So here is your transformer, and it's even stating right on it that it's a 40 VA, come on computer, 40 VA transformer. Secondary is 24 volts. You can see here, this section here is you can see that's a transformer, and then here is where your thermostat wires land. Now when you're looking at the thermostat wires, you can see 2 sets of thermostat wires. 1 set here and 1 set here. This one here, which goes up, has to go outside to the contactor, to the condenser outside. So so if I follow my wiring, there's two wires here that are going to hit that contactor. This section here is going downstairs to the thermostat downstairs. So this is your heating, cooling, and fan operation thermostat. And then looking at the wiring that goes here to the supply fan motor, okay? Oh, by the way, I should mention that I got this unit here's the plug. There's the plug right there. I'm unplugged. So everything in here, there's no electricity live. I'm not going to get zapped. Okay, now again, I was looking at this wiring because I wanted to figure out speeds of this motor. So that's one of the reasons why there's two reasons why I took this out. The one reason is because I want to determine what color does what speed. So to do that, you have to look at the data nameplate of the motor. So here's the motor. I come down here, and this data nameplate is just completely buried by the bracket that holds it in place. And you can see all the dust that's there. So I'm going to take my shop vac here, and I am going to clean this motor up as best as humanly possible. And I'm not going to take it apart so I can determine exactly what speed is what. This is all original. It's 40 years old. I don't have an issue, so I'm not at a point where I feel like I need to troubleshoot and figure this out. But if I needed to, I'd have to take this thing physically out off of that bracket so I could see the plate right there and see what's going on. No technician labeled it what color does what and whatever, so I don't know anything. Here's the capacitor for the motor. All right, so here's the capacitor. Now, first of all, I should mention that, okay, the electricity is off. I'm going to discharge the capacitor by just shorting out the two ends, just to make sure that this capacitor is not holding a charge. Now, I'm just going to take it and just move it up so I can check out that rating. All right. And just tighten this back down. All right, it looks like that is 7.5 microfarads. Let's throw my meter on it. The meter, when I get this camera in it tight, it kind of loses focus, but that's the best I'm going to get. Okay, so for my meter, I've got a field piece, SC77. You're going to take your meter and you're going to put it on microfarads right there. These meters, I think I got this meter for like $200. So I switched out my leads from the standard terminals like this, and I put on my alligator clips so I could, I don't have to hold two things simultaneously. To make sure that you've got a good connection inside here, because you're doing that connection, I'll do a continuity check first. So just put it on continuity check. Okay, good. We have continuity is good right there. So I know that that's a solid. I know that my meter is in right. I'm going to get a right reading. So now take this, bring it over to microfarad right there, and now take our leads. The capacitor's already been statically discharged. Okay, so this capacitor is rated at 7.5 microfarads, and I pulled one of the leads of the capacitor. After, I made sure it was statically discharged. The electricity is off to the unit, so I'm totally safe. Statically discharged, meaning it's not holding a charge anymore. Then I pulled off one of the leads of the capacitor. Then I took my field piece SC77 and I put it on microfarads, and I am getting 8.76. So it's technically it's a strong capacitor because it's rated at 7.5 microfarads. So this capacitor is fine. It's doing fine. So I'm going to put this back to normal. All right, so I just put the capacitor leads back together. I'm going to leave it out like that so you can read the plate on it. But I wrote down 7.5 microfarads just because it's a little difficult to see it right there. Just in case that writing gets any worse, I wanted to write it down. So I always have a black Sharpie right near me so I can always label whatever it is I'm working on. Okay, so the next thing that I want to do while I've got this thing apart is I'm going to take my shop vac and I'm going to try to clean this out. I'm going to put it on suck mode, try to clean it out, then I'm going to put it on. Okay, so first what I did was I put my shop vac here on suck mode, which is the hose here was connected inside here. Then I just tried to suck out as much dust as possible. Then I put it on blower mode here. Oh, who's this? What are you doing? Get over here. So then I took this here and then I put it on blow mode, and then what I did is I went and blew out as much as I could. Now what you're trying to do is you're trying to get the dust out of this motor because you want this motor to breathe and not overheat. Dust is going to overheat these motors, so you're looking at your windings down there and stuff like that, and you're just trying to keep everything clean. And I tried to get inside here as best I can, but some of the on the outside it's a little caked up there. But anyways, I just tried to get it as best I could. All right, so I'm going to put this back in place right now. All right, when I go to put this on, this flange of this blower housing mates with the rail that is located. There's two rails. There's one here and there's one on this side over here. So basically I just have to put it in, slide it in, and then push it back all the way, and then a couple bolts, screws. Alright, so I just want to show you those two screws that hold this in place. So one screw is right there, the other screw is right there, and then it's just held in place on the other side with a retaining clip. One there, one there. So blower wheel is all set. I was not able to determine the speeds because I couldn't take that thing apart, and nothing's labeled, so I'm going to let that go for now. Now, just the way that this system operates is that over here, hold on a second. Okay, so you've got your plug here, okay? Plug power, which is 110 volts, okay, comes in to right here. It comes into right here, and then they split up, and then it splits off on the cord, okay? One of the lines goes to all this white, so you know that's your neutral. This line over here is the hot. So then if I take that hot and I just kind of look at it, it goes to this black wire nut, and then they disseminate off with the incoming wire, this one, and then they go off in a couple of different directions. One of the ways that they go off is they go up to here, which goes to this line right here, that line right there, which is this item right here. Now what is this item? This item right here is a thermostat currently set at 95 degrees Fahrenheit. What that means is that when the heating comes on and the heat exchanger inside of this furnace heats up and that temperature gets to 95 degrees, it will close this switch, energizing this black leg. This black leg, if you follow it, goes, let's see where it goes. It's this line right here. It goes to this red line right here, and then ultimately what it's going to do is it's going to power up this fan. Now, on the back of this contraption here, they provide okay, who's the manufacturer? Let's go through the data nameplate. Here is the furnace data nameplate. So Gaffers and Sattler Inc., Los Angeles, California. There is your model number, U100-1. Natural gas. Input is 100,000. they call it the bonnet capacity, or the output is 80,000. So we know it's an 80% furnace, 100,000 BTUs in, 80,000 BTUs out. You don't even need to do the math, it's already done for you. It tells you that from 70 to 100 at a 0.15 inches of water column static pressure. The electrical rating is rated at 5 amps, and this gives you your clearances from combustible surfaces: 1 inch on the top, on the sides, the back, and you are allowed 6 inches in the front. So here's the front of the unit where we come to our closet door. 6 inches here. You need a minimum of 1 inch here, so you got more than 1 inch there, 1 inch here, and then 1 inch in the back. Now, when it comes to combustible air, what you need to do is you need to make sure that your closet has combustible air, either with a vented door, a louvered door. In my case, my combustion air is back here. You can see that grill, and then if I follow that, it goes back up into the attic, and I made sure that that was nice and clear. So that's how this furnace gets its combustible air. Now, as far as the furnace filter goes, this, like I said, I've been in this house for about 9 years or so, and here is the air filter. This filter was here when I bought the house. I have not had to purchase a filter in 9 years. This is what it looks like on the down upstream side of the filter. Alright, so and here's the filter itself, okay? And it's one of those washable air filters, okay? So I just take it outside, use a garden hose, and I wash it down. So lucky for me, I haven't had to purchase an air filter in years. Now, how good of a filter does this do? I think it does a pretty good job. When I wash it out, you can see a lot of the lint and debris caught inside here, but they probably have better filters today. This one was, like I said, it was already here. Let's see if there's a sticker on it. There's a sticker right here. And the sticker is almost to the point where you can't read it. It just tells you the direction of airflow. I don't believe these have, and the airflow doesn't matter whether it goes one way or the other. You can swap these around. I don't think it's directional, but in any regards, this is the air filter that I have, and they want the air to go up this way. So let me go ahead and put that in. What are you doing? Did you get scared? Alright, and as long as I got this open, I should probably just show you what it looks like down here. Alright, so now that we've got this open, we can actually see what it looks like. There's the natural gas pipe right there. This here is the opening for the airflow to come up the chase from the first level. Now, let's see if I can show it to you. So that goes all the way down to the first level. And these filters, they just basically, once you get them lined up, they just kind of slide right in. Make sure that they don't get hung up here, and then push them back all the way into the unit there. Alright, so that filter is fine. Okay, so we checked the capacitor, we cleaned out the fan, we tried to clean things up there. This wiring, I just wanted to kind of take a look at it, but there's a couple of doors here. I'm going to put those back on. This door goes here, and this thing, transformer, goes right there. So let me put those, get those secured. We don't need them anymore. Okay, so now looking at the natural gas, I have the valve shut off right here that comes in to this line, this aluminum line right here, that comes over to here, to my gas valve, and then goes into the manifold, and then comes down and feeds the 3 burners. Okay? When you're looking at the burners, there's an opening right where my finger is going in right there. That's where the primary air gets sucked into the burner tube, where it goes to an orifice where it goes into the heat exchanger for combustion. This is the manifold. There are 3 burners. The air that goes around here and where my hand is now and going into the heat exchanger, this is the secondary air that for complete combustion. Now, these here are adjustable with a Phillips head screw right here. This unit is so old that I don't even have a tap on the valve to determine what the manifold pressure is, number 1. Number 2, my data nameplate doesn't even tell me what the correct manifold pressure should be anyways. And this thing is so old that I can't even go to the manufacturer, put in the model number, get the spec on this, and determine what the correct orifice size should be or what the correct manifold pressure should be. Because back then, they didn't even have the internet 40 years ago. So it's you know, I'm just dealing with ancient technology. But as long as I'm here, let's take a look inside. Now, what I'm doing is I'm performing a visual inspection. So I'm going inside here and I'm looking for anything that looks like cracks, anything really weird, whatever. I'm checking each one of the burner tubes individually, and I'm just looking for things that are striking to me, okay? Now, I do see some debris. This one here is the worst. All right, see all that debris down there? I kind of don't like that. I got my shop vac here. I want to get that cleaned out. Accessibility is really, really tight. I can't even get my finger in here. Never mind try to get my shop vac in there. It won't fit, right? So I got to pull this out a little bit to at least get my shop vac in here. So what I'm going to do is I've got this valve off right here on natural gas. I see 4 screws, okay, 2 on this side and 2 on the other side over here. I'm going to take these 4 screws out. I'm going to see if I can just take this burner assembly, lift it up in an effort to get my shop vac. I'm going to switch that around from blow to suck. And I'm going to see if I can get my shop vac in there to kind of clean that out a little bit. I just want to try to get that a little bit better. So I'm going to work on that right now. Okay, I took out the 4 screws, 2 on this side, 2 on this side over here. This is loose, so it's just being supported by that. This plate right here is kind of blocking me. I want to take that out now. There's 2 screws that hold that in, one right there and one over right there. So I'm going to go ahead and pull this plate out and see if I can get this a little bit better accessibility. Well, that totally helped. I can see inside the heat exchanger cavities pretty good here. Still blocked. It's, you know, going to be so easy to take this off right now. All I have to do is break that connection right there and take off this yellow wire down here, this wire right here, this red one. And what I'm going to do is I'm just going to take my cell phone, take a picture of this so I can see all the wiring, how it's displayed before I take it apart. That's always good procedure, is to take your wiring, take a picture, then take it apart. So in case you forget how to put it back together, you know how to do it. What are you doing? Tico, what are you doing? Don't you get in trouble. Alright, everything's disconnected. I got a couple of pictures here. I'm going to disconnect this gas line. Gas valve is off. When I do this, I want to use what's called the double wrench technique. So I'm going to hold one nut while I use the second nut to take this apart. So I don't want to disturb that there. Let's see if, there we go. There we go. Now, also that gives me a good chance to look everything over pretty well. All right, so all right, I've got everything cleaned out. Now let's just go ahead and inspect each one of the burner tubes. I think I'll clean this one out a little bit better. I can still see some debris there on the right. Let me go through this one more time. Get this one more time off camera so I can shine the light and do that simultaneously. Okay, I went through and used the shop vac again, and I cleaned up as much as I could one more time. Now I'm going to take this old rag and I'm going to put it inside here. Let me show you exactly what I'm going to do as an example. I'm going to put it inside here. I'm going to wipe as far as my hand will allow me to go on the whole inside surface, and then I'm going to shop back all that up again. So this way, in case there's any cracks or anything like that, I'm going to use my flashlight to look for any type of anything I can see here with my eyes, just to see if there's anything right here. This is the hottest point of the system, right where the flame is at, so the greatest chance of cracking should be hopefully right here at this local surface. So I'm going to go through each one of these tubes, heat exchangers, each one of these burner tubes. I'm going to clean inside as much as I can, use the shop vac again, get all the dust out, then perform the inspection, and then I'll take you guys with me on the inspection so I can show you what I'm seeing. All right, I got done with that on each 3 tubes. I got a lot of surface rust that the rag took off, and now I'm going to use the shop vac to go through the tubes one more time and clean that up. I had to wash my hands because it's such a dusty job. Anyways, I had to wash my hands, and this is a bathroom that I did a full remodel on, and installed this tile with this glass and the niches over here. So if you want to see how I did that, you can check on my channel, Ken Training, and I got a complete video on how I built this entire bathroom. There used to be a door right there. I took it out and textured the entire bathroom, put the vanity in, put the mirror in, and put the flooring down and replaced the toilet. So I got a whole video on the whole thing. Okay, I went through, shop vac'd up. I already did my own inspection, but now I'm going to show you what I'm looking at. So now that everything is super clean, I go inside of each tube, each burner tube. I start at the bottom. I go on the left side. I'm looking at the sidewall, and I am trying to see if there is any crack on the sidewall at all. Then I go to the back. I do the same thing for the right, and inspecting everything, come out, and then move on to the next tube. Start at the bottom, check everything out, go to the left side. Anyways, I've already gone through all 3 tubes on my own. I cannot see, I'm trying to get you the best camera angles possible, but you know, it is a burner tube. And then here's the one on the right. Anyways, I cannot see anything, okay? I'm looking for a crack, I'm looking for something weird. We're gonna turn the burners on. We're gonna do some more inspecting here, just to see if there's anything squirrely going on here, but from just doing a visual inspection, nothing is evident. There's the furnace right there, and here is a CO detector. I have two CO detectors, one at this level and one on the first level. And then in case this heat exchanger begins to crack and CO is coming into the supply air, these CO detectors are supposed to warn you that, okay, the air is becoming unbreathable. So there's that level of insurance that every house that has a natural gas appliance should have CO detectors on each level of the house in the common areas. Okay, so the premise is that let you know I've got that level of insurance at this house. Okay, the burner tubes are 100%. I'm ready to put these back in. While this is out, we should take a look at the thermocouple. Okay, so looking at this is your pilot right here. Your pilot flame comes down to this section right here where it comes out. And this is the thermocouple. There's normally two leads that go to the thermocouple. I have one of the leads disconnected so I could pull this assembly out. Then you can see one lead of the thermocouple goes to the gas valve. The other, so what happens is it comes the one wire, the yellow wire. There's two yellow wires that I disconnected, if you remember. That was this wire and this wire here. So this wire goes to the thermocouple. This yellow wire here goes to the gas valve. So that's how you complete the circuit. So the thermocouple is telling the gas valve, hey, I've got a flame, it's okay for you to open. This is how the system operates. This produces a little mini voltage that operates a coil in here that allows this valve to open to allow the gas to go through into the burner manifold. While I'm looking at the burners, I'm looking for anything dirty, whatever, anything that's out of the ordinary there, but I'm not going to adjust these primary volume dampers here for the primary air, because I'm going to just make an assumption that everything is preset either at the factory or whatever. We'll check our burner operation when we get into it. Now, as far as this thermocouple goes, I think I'm going to get a little wire brush and just clean that off a little bit. Alright, so I have a little wire brush here, and I'm just going to take this, even though this thermocouple works, just going to clean it off, clean off everything here, just to make sure that everything is this just doing a preventive maintenance just to make sure everything is clean, give it the best chance of running. Alright, that's it. Now, as far as the angle of this thing goes, as far as I know, it's discharging onto the thermocouple fine. Looks like it comes out two ports. There's a lower port there and an upper port there, but I'm not going to mess with that. As far as the burners go, as long as I'm right here, I am not sure if there's much I can do here. Guess I could run my rag. There we go, like that, and that's it. Alright, I'm going to go ahead and put this whole thing back together, starting with that metal piece that I took out. So just going in the reverse order, put this piece back in, then put the burner in.